We're all doomed. The planet's going to hell in a handcart. We keep getting told that global warming is unstoppable, and we might just as well put a bag over our heads and give up now. Asia has to take more than its fair share of stick when it comes to greenhouse gases. It's come late to the industrialization party, but since it arrived, it's been hogging the dance floor and eating all the dips. That's because Asia has become the world's factory, and that means loads more emissions. But as a continent that's changing faster than you can blink, it's also the natural home for a special group of people who aren't tied down by conventional thinking. They're scientists and activists, movers and shakers, and they're coming up with some unexpected, even crazy solutions to the problems we all face. We humans just love to do stuff. And doing stuff requires energy. If we want to do stuff at home, or in the office, or in a factory, it uses energy, mostly electricity. And if we want to move stuff around, well, that needs energy too, usually oil. But producing all that energy means greenhouse gases. So the Changemakers are out finding new sources for oil. Or taming the sun. Or using new kinds of fuel. From chemicals to other kinds of chemicals. Adapting old technologies and dreaming up new ones. All so we can keep on doing stuff. Plant sex. Just by helping the right pairs of plants to get jiggy with it, using tweezers, one set of changemakers thinks they can cure humanity's love affair with petroleum and all the CO2 output that driving entails. Crude oil comes from the corpses of untold billions of microscopic prehistoric creatures, so the CO2 released by driving has been locked up underground for millions of years. And we don't need it back. So, the argument goes, don't use fossil fuels, use biofuels. Made from contemporary plants, not from dead dino bugs. Just a couple of problems here. We need all our fields for food production. There's not much point feeding our cars if we can't feed ourselves. Anyway, the standard oil plants can't produce enough. So what we need is a plant that'll give us a whole load more. Meet Jatropha and its patron, Mr. Jaya Kumar. Its party trick, producing way more oil than any other oil-producing land crop.
We look at 4 to 5 million metric tons of biodiesel production per million hectares.
It's a species that originates in South America, where the indigenous people have always valued it for its medicinal properties. The Portuguese are reputed to have brought it to Africa and India in the 16th century, and it became known for the oil derived from crushing its nuts. Useful for lamps, but mildly toxic, so useless for salads. Jatropha's biggest advantage is that it grows where food plants can't. It can take over scrubland, wasteland, anything but food crop land. It even survives droughts, storing the little water it needs in its fleshy stems. Getting diesel out of Jatropha is simple.
Once the seeds are harvested from the plants, we get the seeds from the Jatropha plant, which you can see it here.
When they're crushed, they give up oil, a massive 30% of the nuts. A field of Jatropha can produce 10 times as much oil as a cornfield. The oil can go straight into a truck, though ideally it goes into a converter.
And this crude oil actually goes into this small unit. The entire process takes about 48 hours to convert into the biodiesel.
There it's mixed with a nasty cocktail of methanol, caustic lye and sulfuric acid. turning it into pump-ready diesel. Possibly not the most eco-friendly of processes.
This is how you can put it into the vehicle once you have the crude oil. Once you have the biodiesel, you get the de-oil cake. This is where the de-oil cake is, which will go for the organic manure, which will again, it's basically to rejuvenate the plants in the farms.
Of course, it's never that simple. The wild jatropha plant still isn't really productive enough. So you've got to breed a bigger, better jatropha plant, which isn't as easy as it sounds. Plants are like students at a high school dance. Not too fussy about who they mate with, as long as they're of the same species. But that haphazard approach doesn't mean you'll get the best results. So, Mr. Ram Babu is matchmaking for 2 jatropha plants. He's found a good target plant, and he's setting about emasculating it. The offspring, he hopes, will be plants optimized for biodiesel production. Out go all the reject male flowers. Then he introduces a male flower from another plant to the remaining females, all in the interests of good breeding.
Honestly, darling, I love you.
The tender moment over, discretion and protection from random pollen. A newer, better generation is assured. When the right combination of plant stock and cultivation techniques is found, the new hybrid gets a patent slapped on it. After all, with the hunt on for replacements for oil worldwide, there's plenty of competition. Already, young plants are being prepared for trial projects all over India. Jaya Kumar has faith in the world-changing potential of his nuts.
Jatropha is a plethora of opportunity. This is going to change the ecological and environmental perspective of the country, to start with India, and we would like to take this technology outside.
But there's just one hitch. Even at the production rate they hope to achieve, current world oil consumption would require around 8 million square kilometers of land, roughly the area of Australia. Do we really have that much land to spare? Not every country is blessed with masses of spare tropical scrubland, especially not the world's biggest car producer, Japan. So a plant that produces many times the amount of oil would be handy. And the good news is, we may have found one. Time to look at slime, green slime. In a small lab in Japan, the slime professor is hard at work. He's identified a strain of goo with a remarkable property.
So this Fertilizers brownie, so oil producing green algae, produced the oil with high purity composed of cyclohexane or ketone or epoxide. So usually most of oil producing algae accumulated oil inside the cell. But this alga, Fertilizers brownie, excreted the oil from their cells. So it is a very particular characteristics of this species.
Fortunately, there's a friendlier way of putting this. It's a kind of green algae, and while many types create oil, this kind actually oozes it, making it easy to harvest. Algae live in water, and they use the oil so they can float. If they sink, they're in the dark and they die. And we can definitely use this oil to help maintain current lifestyles while not adding to greenhouse gases.
Then Botryococcus absorbs the CO2 from the atmosphere. So this algae very, very useful for reducing the CO2 from the atmosphere and produce the oil for future energy resources.
For years, the professor has been studying the algae. He's looking for the perfect slime. One that doesn't need too much mollycoddling, that is happy with a wide range of temperatures and doesn't demand too much light. And still produces lots of oil. The professor reckons could deliver 120 tons of oil per hectare. As ever though, there's a hitch.
So it is very easy to culture this species in the laboratory, but relatively difficult to culture in the outdoor systems.
That's because these algae need fresh water of a certain depth and temperature to flourish, which could mean expensive breeder tanks. In crowded Japan, there might be no alternative with land being at such a premium. But the professor believes that can play its part for the good of Japan and the world.
My dream is to change Japan from oil imported country to oil exporting country in future. It's my dream.
He's nothing if not an idealist.
Since I am researcher responsible for the happiness of the world, so I must carry it out to develop the technology for efficient use of microalgae.
There's a long way to go before this process can be industrialized, and Professor Watanabe has limited resources. But he believes that within a decade, his green slime will be making a significant contribution in the battle against global warming.
Sorry. It's my dream.
What plants are doing is converting the sun's energy through photosynthesis into useful oil, and in the process, are locking up carbon from the atmosphere. The sun ultimately provides every bit of energy we receive on this planet. So why not go straight to the source and tap into the sun itself? Solar power is one area in which Asia is actually having to play catch-up, despite the plentiful sunshine across much of the continent. The trick is to make solar power desirable. Christoph Inglin has a sunny disposition, mostly because he's such a fan of solar panels that he's literally covered his Singapore house with them. That means loads of free electricity. All the more so because Singapore is on the equator, so gets 12 hours of daylight every day of the year.
This is the control room. Converting from the panels on that roof and on that roof there, they generate DC electricity when the sun shines. On the way in, the DC comes through these, and there are lightning surge arresters and a main on-off switch. Now, they convert the DC to the AC electricity and synchronize it with the grid. The AC cables comes out here, goes up through this distribution board with a few safety switches, and then down to the isolator and the main AC distribution board in the house. So then we've got the two parallel power supplies, one from the solar and one from the grid.
The key to getting this technology adopted is first showing how it can save money.
I see the future in the costs are coming down. So if you look 5 to 10 years from now, this will be commonplace in Singapore. People, when they build the house, will say, I want that because it's a cheaper way of getting electricity. The panels will get more efficient, but more importantly, they'll get cheaper.
Installation cost Christoph around $70,000 US. So what, apart from a warm, fuzzy feeling about not burning fossil fuels, is he going to get back on his investment?
Now, in Singapore, when you have a solar system installed on the roof, Power Grid comes along and installs a special meter. And this is the meter. 3,800 is electricity produced by the solar panels in excess of what the house consumes and exported. And 2121 is how much electricity has been imported from the power grid, mostly at night time.
He draws power from the grid at night, when his solar panels are not doing anything useful, and uploads surplus power during the day. So long as he generates more than he consumes, he's in profit. What you need to make this viable is an affluent class with lots of roof space. But with many Asians living in high-rise blocks, this isn't going to solve the world's energy problems entirely.
The thing is, every little bit counts. And in Singapore, we've probably got around 100 square kilometers of roof space available. If all that were covered with solar panels, it would meet something like 30 to 40% of Singapore's electricity needs.
It's a technology that makes a difference, that's popular worldwide. But it's going to be hard for solar to be the only answer. With the sun going down every night, regular as clockwork. Still, in the sunny parts of Asia where car is king, it makes a sort of sense to try to get cars powered by the sun as well. After all, petrol really is on the way out, though it looks like it's going to be an uphill struggle. The sunny south of Taiwan is home to some of the world's most advanced solar energy production. 1 in 4 solar cells are actually made there. So it's scarcely surprising that Professor He Chang-ai of the National Kaohsiung University of Applied Sciences, responsible for solar cell development, is a solar fanatic and even has his workshop entirely powered by solar. Inside, a team of enthusiastic students and a passionately proselytizing professor bodge together whatever their budget can afford in terms of components to make their masterpiece. Mixed up materials, cannibalized computers, pillaged PDAs, recycled silicon solar cells. It's a hodgepodge of pieces begged and borrowed from wherever they can get them. What they're putting together is a prototype, a solar racing car. Solar races draw attention. It's Professor Ai's way of attracting funding and a step on the road towards his dream, getting everyone in a solar car.
下一步当然就是希望有一天街上所有的人开的车都不是在排放那个污染的车子，不一定是太阳能车，电动车也可以。
What they end up with is an aircraft composite made, satellite-grade gallium arsenide toting, lithium polymer-driven solar racer. Once the car's ready to hit the road, there's just one more thing needed to make the car a competition winner. He's not the mechanic. He's not the engineer. He's not the bloke in the yellow shirt. He's the driver. Though when it comes down to it, not damaging fragile solar cells is probably more important than looking cool. And then, all you need is plenty of practice. To attract the most attention, the car is being entered for the big one. The World Solar Challenge. The Paris Dakar of the weird, flat solar car world. 3,000 kilometers across Australia, from Darwin to Adelaide. Any car crossing Australia is bound to meet many adventures. Probably too many to go into here. Suffice it to say, the car crossed the finishing line after 35 hours, which pleased the Kaohsiung team inordinately. They've proved their solar chops, which allows them to work on projects more likely to make a difference in the real world.
那太阳这样的能量是无所不能的，因为我们人类最终还是要回到太阳的怀抱。
They've got a solar boat, and there's a solar streetcar in the works. What with clouds cutting back the light and night shutting off the supply completely, solar can't be the complete answer. Or can it? A team from Japanese space agency JAXA are planning to avoid all these problems by creating a power station in space. A satellite would capture the plentiful permanent sunshine, then transmit the power down to Earth using a giant space laser. Of course, there are one or two hurdles still to overcome. Giant space lasers are all very well, but all that way up in space, they're pretty vulnerable and inefficient. The further away from the point of use that you produce your electricity, the more you waste. Kohei Hayamizu hates the idea of anything going to waste. And everywhere he looks, he sees a way to generate some electricity for free. Every movement we make dissipates energy. Just walking along, we make waves. When a footbridge bounces as you walk over it, that's your walking energy going to waste in the form of vibrations. The sound you make as you walk along, that's just energy thrown away as sound, vibrations in the air. So, the mild-mannered Kohei of Keio University in Japan has decided to harness all this wasted energy.
これ日本の伝統的な履物で、下駄というふうに言います。で、この下駄もですね、発電床の小さいものがここの間に入ってると思ってください。で、基本的に同じです。で、これは普通にファッションとしてこの下駄の下がですね、こう地面を照らすように LED が地面を照らすようにしてるんですけども、これの応用で普通に靴に応用できるんですね。運動靴とかビジネスマンが履くような靴もそうなんですけど。
The shoes work by repeated compression on the soles, which causes up and down movement of the generator, which converts the movement into electricity. The Japanese style of the shoes isn't technologically critical. And it can be more useful than just lighting up the floor and silhouetting your feet.
LED を光らせるんではなくて充電バッテリーに貯めます。そうすると大体、通勤通学で15分歩くと、PHS ですと大体5分間ぐらいの通話の、電力が賄える。
And there's no reason that actually talking into the phone can't charge it up as well. Kohei's developed a generator powered by sound.
まずこれはですね、人の音声、話し声で、発電するという音力発電装置です。で、まず裏側にここにですね、こう口を当てて声を出すとここで発電します。で、こっちの四角い方は、その発電した電気をですね、整流する回路が入っています。で、またこれ戻ってきてここの LED が光るというデモです。ちょっとやってみます。
There may be more efficient ways of making use of human power. Electric shoes aren't going to close any coal-fired power stations. But Kohei does have plans that might make more of a difference. At roadsides. Japan's crowded cities have a network of elevated highways passing right next to offices and homes. Noise is kept down by erecting barriers. Kohei is suggesting replacing them with energy-generating walls which would power the road lights. How on earth could replacing simple walls with expensive technological wonders be a good idea? In fact, since a high percentage of electricity is dissipated in power lines as heat before it reaches the consumer, this local form of generation actually makes a kind of crazy sense. And remember the wobbly bridge? Kohei's developed a device for that too.
で今は揺れてないので発電してないんですけど、これちょっとこう揺らすと発電している LED が光ると思うんですね。
The chosen site for a trial of this system is a bridge on the outskirts of Tokyo. With 2 levels of cars and trucks thundering over it, there's no reason why the safety lights can't be powered by his vibration boxes. Kohei also had a trial in Tokyo's busy underground system. He reckons that with thousands commuting to work at predictable times, their combined walking energy could amount to, well, something usable. He didn't fit them all out with electric shoes, though. Instead, he inverted the principle and made a generating floor. With so many people flooding through, even generating just a fraction of a watt apiece, the gates could be entirely self-powered. Kohei's lateral thinking is compelling. He dreams that one day every road in the US will be a power station. Currently, though, there's only one place where Kohei's generator floor is in use. In an office block housing one of Japan's leading office supply companies. An electric floor leads the visitor towards the office of the future. Each step on a pad lights up the one in front. It's an exercise in awareness raising. The heavier your footfall, the happier the little light bulb gets.
経済的という意味ではまだまだ発電量にもすごく限界がありますので、なかなか実用までに発電量はないんですが、大事なのは、社員ここに働いているワーカー一人一人が自らが発電するということを意識させる、それがすごく大事だと思ってますので、歩く人の振動によって発電する、これがすごく大事だと思ってます。
Inside, the office is divided into 2 parts. The old-style office, with its orange lights, and the new office. Here, workers are encouraged to sit next to the windows to make use of the natural light. And with the lamps balanced for daylight, there's no distraction. Low-energy LED lights are used. And the workers, normally encased in stiff business suits, are encouraged to dress down. In summer, this means the air conditioning can be kept lower, an enormous saving in power, even with just 1 or 2 degrees difference. Other simple measures include having meeting rooms also lit by LEDs on a timer. The meeting must be scheduled in advance, and when time's up, the light goes off. Focuses the mind wonderfully.
大事なことは、一から全部作り直すのではなくて、今あるオフィスをいかにこうリデザインし直しながら、いかにエコに近づけていくことが大事だと思ってますので。
Even these small measures show how straight-laced Japanese companies are taking global warming seriously. They make it their own responsibility, and with very little effort, can save around 20% of their power consumption. Asia can get pretty hot, especially in all the shiny new cities that have sprung up around the tropics. People keep cool with Aircon. And Aircon uses a phenomenal amount of energy. In Singapore, where Aircon is a way of life, almost 80% of power used in buildings and 50% of all electricity used goes on Aircon, which makes Singapore an ideal place for an Aircon eco makeover. All that Aircon belts out heat, making the streets even hotter. In one of those hot streets, there's a tumble-down former hotel. And scattered around, bits of green technology. Entrepreneur Philip Lee has decided that enough is enough when it comes to all that hot air going to waste. Most of this stuff is to do with solar water heaters. But Philip's real brainwave is one of those ideas that's so obvious that you get very, very annoyed with not having thought of it yourself. It's an aircon-driven water heater.
Here you have the normal aircon, the indoor unit itself. Over here, this is the outdoor condenser unit. And this is our aircon heat recovery tank system.
After cooling your room, the coolant circulates around the hot water tank, heating the water.
Over here, you can see the ambient temperature is about 30 degrees centigrade. It very quickly increases to about double that. It's about 75 degrees now. And you can see plenty of steam coming out of the hot water heat recovery system.
By the time the coolant leaves the water tank, it's lost most of its heat, and the aircon refrigeration unit has less work to do. It's a classic win-win situation.
We get hot water free of charge. We get enhanced cooling for the air conditioning system and increased efficiency for the aircon itself, because we are extracting most of the heat that would have gone out through the atmosphere in any case. And thirdly, also, you're not burning any fossil fuels to produce hot water in the process.
The unit is proving popular, even at the typical eateries of Singapore. Mr. Loy uses one not for his aircon. He doesn't have any. His restaurant's open to the street. Instead, he had Philip hook one up to his ice machine. Every day, he gets through enough ice to fill a small skating rink. That means plenty of refrigerant circulating around. Instead of the heat from the back of the fridge belting around the already sweltering kitchen, it's diverted up through the water tank. And the hot water is used to make Singapore's signature coffee in a sock. He may not look it, but Mr. Loy is a happy man. And his customers may not know it, but they're at the forefront of green innovation. While it's an improvement in efficiency, the aircon system still needs electricity to run, which more than likely comes from a dirty coal-fired power station. What the Changemakers are after is a power source that's as pure and clean as the stars themselves. With climate catastrophe looming on the horizon, you would think a changemaker would be doing something more useful than playing with toys. In fact, this is the only car currently available on the market which is powered by the ultimate clean fuel, hydrogen. Hydrogen is what powers the stars. They fuse hydrogen into helium and ultimately other elements. Though earthbound fusion reactors have proved remarkably fiddly to make workable, and you're not going to be able to strap one onto the back of your car anytime soon. The boys at Horizon, a company now finding its home in Singapore, have decided to think small before they think big. So they're making toys powered by hydrogen. Fun and educational. All you need to make hydrogen is a power source and some water.
The membrane is extracting hydrogen from water, and you see bubbles here appearing in the water. That's oxygen. And on the other side of the membrane, we have hydrogen being formed over here. If I take this hydrogen and I run it through a small fuel cell, you will see electricity being produced.
A fuel cell. Essentially, it's a battery that never runs out, as long as you keep topping it up. Plug in hydrogen, add some oxygen from the air in the presence of a catalyst, and bingo, the chemical reaction gives you your water back, and electricity. Unfortunately, the catalysts generally use platinum, which is famously very expensive.
And it's not very easy to reduce the cost of the technology. However, there are ways to minimize the use of the materials. So in this sense, Horizon was able to create products that could be sold into the retail market.
Toys are useful indoctrination devices. Kids playing with the cars and their little hydrogen fueling stations will accept the fuel more easily when they graduate to grown-up cars. And they're a useful stepping stone for the company as it moves on to bigger devices.
Horizon has always been working on larger applications, but it doesn't really launch the applications until they are fully ready.
The latest invention isn't entirely powered by hydrogen. The ultimate green fuel is in fact breakfast. Take a couple of bananas and a good strong pot of coffee and combine them with an energy amplification system and you've got some pretty nifty linear motion. Though that's not always enough. You can run out of puff at any moment. What you need is a super bike. Dolph is from Bike Crazy Holland, so obviously the project is his baby.
This is the HMX, which actually stands for Hydrogen Mobility Extender.
Or in other words,
it's a hybrid in the way that it uses human power as well as hydrogen power, fuel cell power.
It's not for the completely lazy though. You have to put in some effort yourself. It's still a bicycle.
Designed to give you a one-on-one assistance. So whenever you're pedaling along, the motor will sense that you're actually pedaling and it will help you with the same amount of power. This actually contains the fuel cell as well as the electronic controller inside. So basically it needs oxygen from ambient air and it uses hydrogen from our storage here to provide electricity to the motor. So it's ready to go. I press on for about 2 seconds and it goes.
Your completely green, emissions-free daily commute is a lot more attractive if you've the strength of 2 men. Simple as hydrogen power seems, there are a couple of well-known snags. You don't want one of those going off underneath your bottom. In fact, there are ways of storing hydrogen in metal compounds, not as gas.
This is actually a solid-state form of storing hydrogen. The pressures are extremely low, it's about 5 bars, which makes it very safe and very practical to use.
One set of canisters powers the bike for 300 kilometers. And if it's a cheap and effective way to carry hydrogen about, this opens the doors for all kinds of applications. From emergency power packs to backup power systems, to boat engines, to bigger backup power systems. Wherever you need a power source, you can stick a hydrogen canister. Hydrogen power is forging forward. But there's one change-making idea floating about that's struggling to be taken seriously. Not least because it's associated with the conspicuous failure of an earlier science mega-project. When you're not using solar power, you could always use lunar power, in the form of the tides the moon causes. Professor Minoru Takeda in the seafaring town of Kobe in Japan is a cryogenics expert, a scientist who deals with really cold stuff. He's coming at the idea of getting electricity from the tides and currents of the sea from an unexpected angle.
我々はもともと超電導電磁推進線の研究をやっておりまして、 この研究の逆の原理を利用することによって、海流のエネルギーを電気エネルギーまたは水素エネルギーに変えることができるのではないかという着想を得て研究を始めたわけです。
The story begins before 1990, when a Japanese conglomerate came up with a whole new concept for a ship's engine. It was called a magneto-hydrodynamic drive. They still hadn't found a better name for it when they started building a prototype, the Yamato 1. Water would pass through a tube running along the ship. If the tube was surrounded by a giant superconductive electromagnet and an electric current passed through the water, the physics dictates that the water would be expelled, which would create propulsion. It's called the Lorentz force, after a Dutchman called Hendrik Lorentz. He was friends with Einstein, which suggests his science was probably pretty good. The scientists did their sums and predicted that the magneto-hydrodynamic drive would be a great success, more so than the name, at least. A 9,000-ton submarine could reach 60 knots, they reckoned. It was as important to Japan as its space program. It cost $52 million and took 6 years to build. It had 2 thrusters, each with 6 ducts. Onboard diesel generators would supply the electricity to power the electromagnets, to keep the liquid helium cool, and also to provide the current that would set off the Lorentz force and propel the Yamato 1 forward. When it was launched in 1992, it looked sleek and modern, in the same way that the DeLorean sports car had done a decade earlier. It was about as successful as the DeLorean as well. Despite all the song and dance at the launch and the glossy aerial footage, nothing could hide the fact that it was slow, not managing more than 7 knots. The boat was quickly mothballed. Professor Takeda joined the research team to try to improve the engineering. But then he thought of something really rather clever. He could reverse the whole thing and turn it into a green power station. All you would need to do is drop a superconductor tube into the ocean, and the tides rushing through the tube should produce an electric current. Too good to be true? Well, we don't know yet. The idea remains just that. Professor Takeda has published papers outlining how the principle would work, but as yet has little funding for the project. And so he has to work on other cryogenic research with his students. It's frustrating. A scientist with no outlet for a good idea is not a happy bunny. But he looks to the future.
20年後ぐらいには実際にその海流熱電発電の装置が世の中で認められるというようなところまで持っていきたいというふうに思います。
Much of Asia is still developing, and lifestyles pretty modest. So high-tech green energy solutions aren't always appropriate. It might make more sense to use what you have to hand in abundance. In the case of rural India, this can mean spirituality and, cow-poo. The Art of Living ashram outside Bangalore is a retreat where groups and individuals come to meditate, find themselves and be at one with the planet. And it's all run on green principles. Caring for the environment is just an expression of their Hinduism-based spirituality. According to Hindu tradition, the cow is a sacred animal, and killing one is a crime. And here on the ashram, cows means vaults. Up on one of the ashram's farms, Sanjoy Mujambar looks after the cows. A yoga teacher who's having a sabbatical in the cowsheds, he loves his cows. And they seem to love him back. They're all native breeds.
The most important thing is with all the native breeds is the product you get from cow, including milk and cow dung and urine. Everything is very much useful.
He's found a very special use for his cow's chief byproduct. For power.
It's a very simple operation. First we let the fresh cow dung store in this small chamber and mix it with water, keep it for more than 12 hours, less than 24 hours. Then after it is soaked enough properly in water, then you mix it properly, thoroughly, manually, and remove any non-biodegradable particles. And then through an underground pipe, you let the slurry go under this cap, steel cap you see, and there it stays for a couple of days, and in a natural process it is digested there and methane gas is produced.
The gas is routed to a generator nearby where it's burnt to produce electricity, just like petrol would be.
And that electricity is enough for electrifying the whole campus. For this campus we don't need any other conventional power.
The effluent is then run off and used for fertilizing the fields where the ashram grows its crops.
By using different proportion, different mixing of cow dung and urine and mixed them with different kind of herbs, farmers can make all different kind of pesticides, whatever they need to tackle the farm disease.
Pesticides and fertilizers are very energy intensive to produce, apart from any ecological side effects. But cow poo's free and clean, sort of. They'd need a whole lot more poop than they can currently muster to run this sizable ashram entirely off poo power. So the accommodation blocks have their water heated by solar panels. For cooking, though, you need something a little stronger. On the menu tonight, and every night, the crops that have been fertilized by cow runoff. Even the chapatis are made from flour ground on the premises. Meditating is hungry work. On an average day, 5,000 meals are prepared. But when the guru is in residence, up to 35,000 people can come in for a bit of wisdom and a nosh-up. The cooking is all done by steam. It's produced by some rickety-looking boilers. The solar panels can't provide enough hot water for food preparation. These boilers are fed by briquettes, compressed sawdust, groundnut and coffee shells, all waste products of other processes. For the yogi, going green just makes sense.
With modern civilization, we keeping ourselves more comfortable, but we are leaving behind less comfortable earth for the new generation coming. Aren't we doing so by harming the nature and earth? So the more eco-friendly you are, the less harm you do to the earth, the better it is for the future generation to come in.
Climate change is caused by our using energy to do stuff. Our Asian changemakers are all looking at better ways of producing that energy and of making that energy go further. Asia's inventiveness is legendary, and its demand for energy is spiraling just as fossil fuels begin to run out and climate change seems unstoppable. If there is a hope, it's that Asia will solve the problems of the world's energy requirements because Asia's own demands are the most pressing. Watch this space.